So just to introduce myself, Ray Hall, head of sales at Arundo. And I will pause at that point because when sales get up and talk at these events, people start usually doing their email or leave. So, I do apologize if there's a bit of selling in here, but I can't help it. It's in my blood. I used to, when I speak, I usually move around like my predecessor a lot, but at the weekend I was out karting and managed to smash my cart on the last lap into the barrier and damage my ribs. And so I learned a lesson that, age and experience does not keep you in front of the pack. So there you go. So it's an interesting part of learning. All right, so you've started your AI program, what now? And if you look at many of the companies that we visit, they've varying stages. Some have started, some have really advanced, some have created digital sensors of excellence, but strangely none of the business units are actually doing anything, much to the CEO's frustration. So there's quite a broad mix. I'm not going to be able to give you an easy plan of this is what you've got to do now. I'm just going to share with you some observations, a little bit about the market, and then some observations that we've picked up from the many customers across many industries we've been dealing with, and the status of it, and just some advice on what we think helps progress. But just to start with, Arundo, we're a software company. We provide analytics-based applications to help industrial companies deploy this and deploy it quickly. Gone are the days of the old SAP projects that took 3 years and 5 years to deliver. People only want 12-month projects now. They want things quickly. And we deliver, one of the things about us is we deliver our solutions in less than 90 days and get people to do things. Because the great thing about doing things quickly and that has value, that actually means something, is it creates hunger for more success. And that's what our whole ethos is with every customer we work with. We are classed as a startup. We're only 100 people, but we've moved very quickly in our 4 years of existence. Our origins are in Silicon Valley, and we were founded by former McKinsey senior partners. So we have a strong consulting ethos at the beginning, at the center of the company. And we also work closely with Stanford University, who's one of our key partners, and also MIT. So one of the great things about Arundo is when we come to talk to you about deploying machine learning, and somebody says, "Oh, well, let's do reinforcement learning." We say, "Well, maybe let's not start there." But we are bringing some of the latest research and thinking that's in the marketplace to our customers because we're partnering with these academic institutions. Okay, so that's enough about Arundo, and I'm sure you've had quite a lot of it so far. Industrial IoT, so why are we doing it? And, Google went on to, has really helped drive a lot of change. It's really been at the forefront of, and you look at Facebook and the change in the whole social media world is evolved. And outside of the big industrial world, you look at everything we do in our day-to-day lives has been changing. So many of you do your shopping for groceries online, and you probably do or don't know there's a machine learning algorithm watching what you do, what you buy, and putting up little offers to you to tell you why you should buy this. And it's just sat there watching you, learning, and every time you log in, it's going to have something else waiting for you. And this is just a normal practice. The same in the insurance industry. They have machine learning algorithms running in the background, looking at churn, why you're likely to leave, so they start to do things around it to try and reduce the churn to other companies. And same with telecoms. Strange how you sometimes get offers just at the right time before you're coming up for renewal for your contract, or some new offer that just happens to be based on your historical behavior. So a lot of these machine learning algorithms are just sat in our daily lives working behind us all the time. We haven't yet adopted this in industry, the heavy industrial asset world, but it is starting to get there. And I think we have to look at this. It's an evolution. I think it's been said before. It's not going to be, an overnight switch it on and everything works. It's going to be a journey because industrial assets were not really designed for data science. The other thing is about sensors. The whole point of sensors. We were at a foods company earlier this week, and they don't have sensors on the equipment they're trying to improve the performance of. And this is a very large company, global foods company. So even just going to the first step of getting sensors so I can gather some data is a challenge for some companies. And the way that sensors are being deployed is also beginning to change. We're working with some sensor companies that no longer charge you for your sensor. They charge you just for the data you utilize, and they walk around, they connect them on Wi-Fi, and they just charge you for streaming data. The sensors are free. And the actual cost of a sensor, based on Electronics Industry Watch, the average cost of a sensor now is down to about 34 cents or something like that. So there's no reason why we shouldn't be putting sensors everywhere. We have securities and so on to take account of. But putting sensors, gathering data, the more data you gather, the more you can do with it within your machine learning models. And the other thing is, compute, a lot of the trends in terms of computing power, cost of storage, and so on, the whole bandwidth, I mean, the fall in cost has been significant. It continues to fall. So it's pennies sometimes to stream data into a cloud to an Azure instance or Google or AWS. These things are not high cost anymore. And so the cost of doing things has dropped dramatically. The trick now is to utilize the new technology, the access to high-performance computing to do things that are maybe you wouldn't have normally thought about. And the other thing is there's a lot of value. Whenever we go to see customers, we talk to them about use cases that they're interested in. We typically, with our customers, will do a use case workshop. Often they don't know where to start, so we help them work through where their priorities are and start to look at and drill down into that one first use case that will be a showcase to say, well, let's start with this because this will be really quick, really good, and really valuable. Let's just deliver this, and then we'll move on to the next one. And it's a great way of getting companies that don't know how to start underway because it builds confidence in what they can do with the data. And when we walk into these companies, the amount of value that can be achieved just sometimes by visualizing data is enormous, and I'll cover that in a later use case that we did. But just getting access to the data, it runs into millions. And we were working with a large oil company that has a topside compressor, and if this topside compressor goes out of production because it fails or has some issue, it costs them 30,000 to 40,000 barrels of production each time. If you multiply that by $70 a barrel, that becomes pretty expensive. So these things are avoidable. The models are available. This compressor models have been done many times. You can start to actually put these in, implement them quickly, and see that you're actually reducing the impact on your production. Okay, so how can I ensure I get some of this value? Well, I think one of the things is how ready is your company? Where are you in the cycle of moving into digitalization? Have you created a digital center of excellence? Do you have a team of data scientists? How are you organized? How connected to the business units are your data scientists? And we see companies at varying levels of readiness. We were working with one company that had invested an awful lot of money in their center of excellence. But the COO's issue was none of the business units were really utilizing any of the pilot type activity they'd done. There'd been a lot of great ideas, but none of it was being actually deployed. And the business units were struggling to understand how it would deliver value. They're just trying to meet production targets, try and keep things running. And when you come to them with another task, that typically doesn't go down too well. And the other thing is we do see that companies look at different aspects. We went to one large company and they said, we're just going to build a data lake. And 2 years later, they're still building the data lake and they're not really deployed a great deal. And it is a challenge. They're expensive. I think trying to deploy a data lake is like trying to hit a moving target. It's always going to evolve and change and grow at a dramatic rate. There's often something you can do with the data you have today. And even if you don't have any data, if you think you have no data whatsoever because I'm just not streaming any data, you probably have maintenance logs. You'll have something associated with your operation. You can always do something if you look at the data around you. Other things that have frustrated companies is that, well, they're very siloed, and also projects taking too long. People, started off with a typical, we'll deliver this use case, but we'll start with the whole waterfall project mentality delivery. So we're going to do a detailed requirements analysis, and we'll do all the typical processes, and it starts to take too long, and people lose focus. And you need to create a more agile organization that allows people to do things quickly. There's nothing wrong with failing, as long as you fail fast and you move on and you learn from it, and that's an important aspect of these things. And I think it's been mentioned a number of times before is getting your data scientists with your operations staff, working them close together. They have different ambitions. But it's surprising when you sit a data scientist down with a subject matter expert, maybe on a piece of equipment or on a process, and they start to look through the data and they identify, well, this was associated with this and this failure was associated with this particular cause. And the data scientist starts working with them on understanding, well, we can detect that and we can build this into the model, and suddenly you start to create this immense amount of capability within the model just by bringing the two people together. Okay, so there are challenges and some ideas and thoughts on what we can do. So I guess the first thing is don't jump before you can walk. Well, I should say run. I don't know why it says jump, but there you go. But what it means is there are things you can do with data. Here's an example. Textile company comes to us, massive ambitions, build a data lake. We need to do complex machine learning across this whole range of processes. So we start off with the use case workshop with them and start to look at what they're doing. We analyze what their priorities are. And the first thing we realize is they don't have any visibility of their 80 plants around the world. And we said, well, what would it be like if you could see all of your plants, operations around the world, and that data was coming to you live, and you could put it in a nice user interface so you could click on a globe and drill down into a plant and see what's working and what's potentially going to, have maybe detecting there's a potential failure. So we did that. It doesn't take long to do this sort of thing. But the one thing we found was the company realized that they had major work processing issues. What that means is they had people switching machines off at the end of a shift, and they had no idea that this was going on across the globe. So suddenly the data had given them immense amounts of insight in what was happening. They changed the working practices, and the efficiency gains were in the order of $30 to $40 million just by getting visibility of the data. Nothing too complex, no reinforcement learning, no deep learning, image analysis, recurrent neural networks, just good visibility of data. Once you've got that, you can start to build on it and do something with it. You can do more to it. You can start to add machine learning. You can start to add more complex. You can look at, if your model's strong enough, you start to look at failure classification. You can develop over time. It becomes a journey for you. One thing about data science is it's very powerful, but it's not perfect, right? It's to think there's a data science model out there that's going to get everything right 100% of the time is probably unrealistic. And that's just reality because machine learning does just learn over time, and they do get better. But the thing is, if you start to implement them, they can help reduce your downtime, your unplanned downtime, your impact on operations or your operational efficiency. You're going to gain something. You're going to improve things. It might not detect every single failure, but it will detect most of them if you've been able to train it correctly. So it's important to make sure that, if you're going to jump into this, have realistic expectations. If your operators are going to actually use this tool that you actually put in front of them, they've got to be bought into using it and understand why it is. And when a new anomaly happens or a new event occurs, they need to work with you to label that data, and then actually so the model continues to learn. So it is part of part of that journey and growing the model and developing it over time. The next one is proof of concepts, pilots. It's important to just don't get stuck in that sort of world. Yes, you've got to try things. Yes, it's okay to fail fast. But we do see a lot of companies still doing lots of pilots, but nothing's been rolled out to the business units. One McKinsey consultant was talking to a large oil company senior executive, and he was asking him how his digitalisation program's going on, and he said, well, I've got more pilots than Lufthansa. So it is something to be aware of, and when you start something with it's a pilot, just think about where the pilot's going. It's important to think about what is the objective, how do we want to roll this out, what will we do for the whole organization. And when you start to put them together, you start, okay, we've done a pilot, we've done a great pilot on a generator, we're able to detect failures on it, the model looks really good. But if you're going to start with that, and maybe you have 50 generators across your organization, have that in mind. Understand, well, if I'm going to do this, how do I roll this out across 50 generators or 1,000 generators, depending on your organization? It's important to have that scale. How do I scale? So if I start with this model, can I create a blueprint that can quickly be deployed and do some bulk training of the model to be deployed across the rest of the assets? The great thing is, once you've got that, you've suddenly now got all of your generators being covered and beginning to learn and utilize machine learning. And the other thing is we often walk into companies and we talk to them about, well, you can gather data from the edge and look how quickly we can connect you up. We can begin to stream data. Here's the cloud. Here's where we'll deploy a model. And then you get the next statement is, oh, I'm sorry, but we really can't stream data live into the cloud because we can't go outside of a country boundary, or we can't do it because of security restrictions, or simply there just isn't communication bandwidth to do it, or there's communication inability to do it, just in a remote area or on a ship. So you don't have to do that. I think everybody recognizes now you can take the machine learning model and just deploy it at the edge. Now the difference is that it allows you to think, well, I'm just going to post results to the cloud. I'm just going to send messages to central operations. I'm going to inform the operator when there's a potential failure. But people can get to see what's happening. Even if it's in a very remote location, it may even just be a simple SMS or to alert somebody that something's going to go wrong. So these things are very achievable with today's technology, very easy to do. And it shouldn't be a restriction that, oh, we don't want to put things in the cloud. It is possible to do things at the edge. Actually, Gartner and IDC, for whatever value you put on what they say, but they claim that by around 2025, I believe it is, that around 75% of all data, enterprise data, will be generated outside of the main cloud. So it's quite significant that a lot more of the intelligence and the operation is going to be done at the edge over time. Okay, and just some final thoughts on what we've learned from our experiences with customers. I can't stress enough, and I think Martin has talked about it yesterday. It's focus on value and the speed of delivery. I think find the value, understand what you can achieve by preventing failure or optimizing your process, and then deliver it quickly and scale it. It creates an immense amount of interest and energy in an organization. When people see success, they just want to get more hungry for success, and it moves and it creates a momentum of its own. The next one is good, well-labeled data is important, but don't wait for perfection. We sometimes see data engineers, data scientists working endlessly, tirelessly through data, trying to clean it up and do this and do that with it and just improve things. And sometimes, well, actually, we can start with what we have. Let's start. Let's see what the model can predict, what can detect, and start to improve it over time with new data. So it's important not to get bogged down in these tasks that we see companies slow themselves down with. The next one is ensure the machine learning AI tool output adds value to the operations and maintenance staff. If this just becomes another alert on top of every other alert the operator has to look at, sometimes they get a little bit of what they call alarm fatigue, and they just start to ignore it. It's got to add value to the operator. I think one of the Accenture reports recently talked about the user interface in industrial assets is no longer important, it's paramount. It's essential that the operators get to see something that is of real value, that adds value. And you can do things such as add rules based around it, so the operator has a means of being able to decide what data he gets to see and what alerts and how he gets to see these alerts. And finally, as I mentioned, there's a lot you can get from your data. Don't think you have to start with complex machine learning models. They're not always the best place. Use the data based on the use case you're trying to solve that's going to bring value. Sometimes just by doing simple calculated values, you can achieve an awful lot. It's just the beginning of a journey. The important thing is achieve the value. Okay, and that's my my view on based on our experience with customers. And if there's any questions, if we've got any time left.
Okay, thank you very much, Ryan.
Thank you.